These are the solutions for the Unit 4 test, comparing and scaling. In the first problem, there are 64 pretzels in a 16-ounce bag, and you're supposed to figure out how many pretzels you get in a 5-ounce bag. So you're going to go from 16 ounces to 5 ounces. And you just look at it and you can tell that this 5 ounces is a fraction of those 16 ounces. What fraction is it? It's 5/16. Imagine you have 16 ounces all lined up and you choose 5 of them. You're choosing 5/16 of the total. That means you're going to get 5/16 as many pretzels. So it's going to be 5/16 of 64. So when you think of this problem, think of pretzels per ounce. So how many pretzels do you get for each ounce? Because that's what you want to know. You buy a 16-ounce bag of pretzels, you get 64 pretzels. You buy a 5-ounce bag of pretzels, well, how many ounces am I going to get? Another word for per, that's that line right here, pretzels per ounce, is pretzels in each ounce or pretzels for every ounce. All the same. All right, so set up the proportion. 64 pretzels in 16 ounces means how many pretzels are you going to get? That's the x in 5 ounces. And here's that fraction once again. It's 5/16. It's 5 ounces out of a total of 16 ounces. So that relationship is going to stay the same. It's going to be 5/16 of these 64 pretzels. So 5/16 is much. 5/16 of 64. So you have 64 pretzels, 16 ounces, 5/16 of 16 is the 5. That makes sense. So then 5/16 of 64 is how much? It's maintaining that same relationship. 64 pretzels for 16 ounces. What's the same relationship if I buy a 5-ounce bag? Well, that means you're going to get 20 pretzels. Now, this is a long way to figure this out. I just like to show it. It's 5/16 of 64. Most of you know that factors of 64, 8 times 8. So you can factor the 64 into 8 times 8. Factor the 16 into 2 times 8. So you're factoring out the 8s. These 8s cancel. You end up with 5 times 8 over 2. You can factor out the 2s. So 5 times 2 times 4. These 2s cancel. And you're left with 5 times 4 equals 20 pretzels per 5 ounces. 20 pretzels per 5 ounces. For part B, we can now figure out how many pretzels you get for 1 ounce. This is called the unit rate. The unit is 1 ounce. And how many pretzels do you get for that 1 or that unit of an ounce? So pretzels per ounce. Pretzels per 1 ounce. So pretzels per ounce, we already know you get 64 pretzels for 16 ounces. That's the same relationship of 20 pretzels per 5 ounces. So now here's that fraction once again. So 1 ounce is going to be 1/5 of this 5 ounces. So I'm going to get 1/5 as many ounces. That means I have to get 1/5 as many pretzels. So one way to figure that out is just divide by 5. 20 divided by 5 is equal to 4 pretzels in 1 ounce. Or use the proportion. And that's the whole idea, is to use the proportion. So 1/5 of 5 ounces is equal to the 1 ounce. So you're going to calculate 1/5 of 20 pretzels is going to be 4 pretzels. That's how many pretzels you get in that 1 ounce or in that 1 unit. So here's x equals 1/5 of the 20. There's 20 divided by 5 right there. And that equals 4 pretzels per ounce, or 4 pretzels per unit. Ounces are the units in this case. In the second problem, a market sells peppers at a cost of $2 for 5 peppers. So cost per peppers, $2 per 5 peppers. Now you go to that market, you pick out 5 peppers, you go to the counter, they're going to tell you that the cost is $2 based on the unit cost. So the unit cost is how much does a single pepper, which is the unit in this case, how much does that single pepper cost? That's the unit price or the unit cost. To calculate that, here's the That ratio, once again, this is 1/5 of the 5 peppers. So if I'm going to think about 1/5 as many peppers, then the cost is going to be 1/5 as much money. So 1/5 of 5 peppers is 1 pepper. So therefore 1/5 of $2 is equal to 40 cents. 1/5 of $2 is the same as that $2 divided by 5. Now I'm going to think in my head, 20 divided by 5 is 4. And so therefore $2 divided by 5 is 40 cents. Once I have that unit cost or unit price, then I can calculate the remainder of this table. So 2 times 40 cents is 80 cents. 3 times 40 cents is $1.20. 4 times 40 cents is $1.60. Here's 5 times 40 is the $2. Now, if I have 5 peppers and I double the number of peppers, then I'm going to double the cost from $2 to $4. If I have 10 peppers and double the number of peppers, I'm going to double the cost from $4 to $8. And right here, I'm just showing you what I think in my head to do the calculations. 1 times 4 is 4, 40 cents. 2 times 4 is 8, 80 cents. Skip ahead up to here. 10 times 4 is 40, that's $4. 20 times 4 is 80, that's $8. Now these calculations are done based on the unit price. You can also think about this as working with the 5 peppers and think about 1/5 of 5 peppers is 1/5 of $2.40. That's essentially what we just did. But then think about what's 2/5 of $2, 3/5 of $2, 4/5 of $2, 5/5 of $2 is $2, 10/5 of $2. 10/5 is 2. So 2 times 2 is 4. 20/5 is 4. 4 times 2 is 8. So you can stop the video, look at these calculations, and see if they make sense to you. For part B, how many peppers would you get if you spent $20? So how many is going to be the X? How many peppers is the X number of peppers for $20? So $20 per X number of peppers is equal to $2 for 5 peppers. Now you could use the unit cost of 40 cents for 1 pepper, but look at the relationship here. This is a little bit easier to do if you're going to spend 10 times as much money. So there's that ratio once again. 20 divided by 2 is 10. I'm going to spend 10 times as much money. I'm going to get 10 times as many peppers. So 20 divided by 2 times 2 is equal to 20. I'm showing you the 20 divided by 2 here to show you this ratio, 20 divided by 2. And that's the same as 10 times 2 is 20. So that's the $20. So you're going to get 10 times as many peppers. 10 times 5 peppers is equal to 50 peppers. And so notice the relationship here. This is $20 for 50 peppers. And if you factor out the tens here, that's the same as $2 for 5 peppers. For part C, you're asked to write an equation that relates the number of peppers N to the cost C. In other words, if you know the number of peppers, how do you figure out the cost? Well, use the unit rate. So it's cost per peppers, or C per N, which is the number of peppers, is equal to 40 cents per 1 pepper. And that's what we figured out before. So now you can use that to write the equation. And this is the ratio right here. So if you are going from 1 pepper to N peppers, you're going to multiply by N over 1. That's the ratio. And I'm going to write this in the same way as I have before. A little bit weird to look at, but that's okay. So this is the ratio, N over 1. You're going to multiply by that 1, which means that if you're going to do that to the bottom part of this ratio, you're going to do the same thing to the top part. So it's 40 cents times N over 1 is equal to the cost. 40 cents times N over 1 is equal to the cost. So the cost is equal to N over 1, that ratio right here, times 40 cents. Well, N over 1 is N. So the cost is equal to the number of peppers times the unit rate, which is 40 cents. And you might be able to just look at this and see that the cost is equal to N, the cost per pepper is equal to 40 cents. So the cost is equal to 40 cents times N. So how do you get to this algebraically? So using the algebra, cost per number of peppers is equal to 40 cents for one pepper. 40 cents divided by 1 is 40 cents. And so what you can do algebraically is to get rid of this number of peppers here, to multiply by n, which means you have to multiply this side by that same n. So you end up with cost is equal to 40 cents times the number of peppers. In part D, you're supposed to identify the constant of proportionality for this problem and basically describe what the constant of proportionality is. So a lot of words here. The main idea is that the constant of proportionality is the relationship between the cost and the number of peppers, n. It is how you get from the number of peppers to the cost. In this problem, the cost is 40 hundredths of the number of peppers. So whatever you have for the number of peppers, you're going to multiply that number by 40 hundredths. That's going to give you the cost. When the constant of proportionality is simplified to the cost per one pepper, that is the unit rate. What is the cost for one pepper? What's the cost per one unit? Once you know the unit rate, which is 40 cents in this case, the cost can be calculated by multiplying the number of peppers by that 40 cents every single time. It is a constant. It never changes. So number of peppers, one pepper times 40 cents is 40 cents. 2 peppers times 40 cents is 80 cents. 5 times 40 cents, 1,000 times 40 cents. Doesn't matter what it is. N times 40 cents is 40 cents times N is the cost. It is a constant multiplier. You can think of this as a factor or a multiplier every single time. It is the constant of proportionality. For problem 3, employees receive a 5% raise. And if the employees make $45,000 a year, what will be their new salary after the raise? So remember, percent means per 100, so it's per cent. So 5% can be written as 5 per 100. So if you say this number is 5 hundredths, and you write it as a decimal value, you say that number, it's also 5 hundredths. So you can use each of these to figure out what the raise will be. So using the fraction 5 hundredths, and actually if you begin with the proportion, as much as you can stand it, as much as you can do, you will be better off mathematically. So 5 hundredths is equal to how much out of 45,000? So here's that ratio once again from the proportions. You're going from 100 to 45,000. That's 450 times. So it's 45,000 over 100. That's 450. Then to go from 5 to x, you also have to multiply by that 450. And I'm going to show that as 45,000 over 100. So same thing. So now you can use this top part to figure out what x equals. So x is equal to 5 times 45,000 over 100. That's the same as 5 times, and there's the 450. So if you factor out the hundreds, that's 450. 5 times 450, and I'm going to use the distributive property to figure this out actually in my head rather than use a calculator. 5 times 500 minus 50, same as 450. 5 times 500 is 2,500, minus 5 times 50 is 250. Subtract those, $2,250. Add that to the raise, and the new salary is $47,250. So this is using the proportion. Most people will not do that. Most people will move directly to realizing or thinking about percent as a fraction of a number. So 5% is a fraction or a portion of 45,000. So that fraction is 5 hundredths, or 5 hundredths as a decimal value and then you just plug that into a calculator and you get that same raise, $2,250. You can continue to use this as a fraction. So 5/100 of 45,000, there's the 5/100 right there, but you realize I can divide that 45,000 by 100, and that's 450. And this one you can either plug in a calculator, or maybe you can see that calculation mentally. 5 times 450 is $2,250. Now you can also do this in one step. I haven't added the salary yet to these, to the raise, but you can actually add the salary and the raise together in the beginning of the calculation by treating it as 105% instead of 5%. So it's 100% plus that 5% is 105% of 45,000. So this is a fraction of 45,000. That fraction is 105 out of 100, or 105 over 100 times 45,000. That's 1 in 5/100. So this number right here is 1 and 5/100 still times 45,000. You use the distributive property just to show you, but you would plug this into a calculator right here and you get the total amount with the previous salary and the raise as the answer. But I'm going to show you mathematically that you can view it as 1 times 45,000 plus 5/100 times 45,000. Multiply each of these separately. This is the distributive property. That's 45,000 plus 2,250, which is what we did over here, right here. Add those two together, and you come up with $47,250. Over here, new salary is equal to the old salary, $45,000, plus $2,250 is $47,250. All right, one more way to think about it. You might realize that 50%, or I'm sorry, 5% is 1/10 of 50%. And you might be able to see that 50% of 45,000, 1/2 of 45,000 is 22,500. Half of 44,000 is 22,000. Half of that remaining 1,000 would be 500. And then 5% is 1/10 of $22,500. It's 1/10 of 50%. Well, 1/10 of $22,500 is $2,250. And then again, add that raise to the previous salary, and the new salary is $47,250. For problem number 4, you're going to paint a room pink. You have two different plans. One plan is 5 parts white, 2 parts red, and the other plan is 7 parts white and 4 parts red. And which plan gives you the lightest pink color? Another way of looking at that is which plan has the most white color. This is a ratio and proportion problem. These are ratios. And so you're going to set up proportions and figure out which plan has the greatest proportion of white paint. So several different ways to do this problem. One is part to whole, and in that case you actually calculate the percent. You can leave it as a decimal value. The other one is part to part. This turns out to be a mixed number. And then also finally you can figure out equal parts red paint and then compare how much white paint you use. So let's start with part to whole. So if you have 5 parts white, 2 parts red, that's 7 parts total. 7 parts white, 4 parts red, that's 11 parts total. Set up the proportion. In this proportion, to go from 7 parts total to 100 parts total, and this is a percent. What percent of this total amount is white? So it's 5/7. So this is going to be 100/7 as much. So 100/7 times this 7 total parts. You also have to multiply the white parts by 100/7. So 100/7 times the white part. That's going to give you how much per 100, which is percent. So you can use this calculation right here. This is x is equal to 5 times 100/7, 5 times 100/7. And if you just keep going through it and thinking about it, you're going to see that this is the percent right here, 5/7 times 100. This is normally how one calculates percent. Change this to a decimal value, multiply by 100, so change it to a decimal value. So that's 71 hundredths, which is the same per 100, which is the same as 71%. Do the same thing with the B plan. So this is 11 times 100 over 11. You're going to increase this 100 over 11 times. So you're going to increase the white portion also 100 over 11 times. So x is equal to 7 times that 100 over 11. So this is the 7/11. So normally you would just look at this as a decimal, multiply it by 100. So this is 64 hundredths, or 64 per 100, or 64%. So which has the greater part white? It's the 71% white compared to 64% white. So plan A is going to give you the lighter shade pink. Now normally as you become more comfortable with these calculations, you're just going to look at this ratio here and you're going to change it to percent. So 5/7 is equal to 71 hundredths is equal to 71%. 7/11 is equal to 64 hundredths is equal to 64%. And of course, you get the same answer. Plan A is the lighter shade pink. Now, if you choose to use part to part as a way to look at this problem, you're going to get a mixed number, but let's set up the ratio first. In effect, what you do is you figure out how much white paint per 1 part red. So I'm going to use half as much red paint to get from 2 parts red to 1 part red. Then I have to use half as much white paint. So from 5 parts white to half that much. So half as much red, I'm going to use half as much white. So 5 times 1/2 is 5/2. Well, there's that ratio right here. And you can just change that to a mixed number. It's 2.5 parts white, but you have to include that it's per 1 part red. So you know what this means right here. 2.5 parts white per 1 part red. Same thing down here. But now you're going to use 1/4 as much red paint. So you're going to use 1/4 as much white paint. So there's the multiplier right there. So it's 4 times 1/4 is 1. So 7 times 1/4 is going to be equal to x. So 1/4 is 7, or 7 times 1/4 is 7/4. So here's that same ratio now written as a fraction. And that's 1 3/4 white per 1 part red. So again, A has the greater portion of white paint per 1 part red. And of course, A is going to be the answer all the time because you're not changing anything, not changing the numbers. Now, most people will look at this and just say, well, let's use the fraction and just change it to a mixed number, and that tells you how many parts you have per 1 part red. So 7/4 as a mixed number is 1 3/4 parts white per 1 part red. So you get the same answer, but it's useful to look back at the proportion and understand where these numbers are coming from and why it gives you per 1 part red. Finally, if you're going to use equal parts red paint, this is similar to part, where that was per 1 part red. This is just changing it to 4 parts red, because I look at this and I see 4 parts red here, and I know I just have to double this to get to 4 parts red. So now I can just look at it, but let's set up the proportion. So it's 5 parts white to 2 parts red. And I'm going to end up with 4 parts red. So I'm going to double this times 2. Well, that ratio is 4/2, which is the same as 2 times. So this 5 times 4/2, which is the same as 5 times 2. 5 times 4/2, same as 5 times 2. Get 10 parts white for 4 parts red, compared to 7 parts white for 4 parts red. So more white paint, so it's lighter shade of pink. So A, once again, is the answer. Now you can just look at this. Very little calculation here. Just realize I'm going to use twice as much white paint and then compare these two numbers. The reason you can do that is because in both cases you're using 4 parts red paint. In problem number 5, a train travels a distance of 2.5 miles in 1/3 of an hour. And so you want to know, how far does that train travel in 3 hours? Now remember, so 2.5 miles, 1/3 of an hour, 3 hours. And so how far you travel in 3 hours is going to be x number of miles. Now you know that miles per hour, or mph, is miles per hour. So use that to help you set up the proportion if you're not sure. So miles per hours is 2.5 miles per 1/3 of an hour. And that's going to equal x number of miles. So how far are you going to travel in 3 hours? So this is the proportion that you can set up. Now this gets a little bit tough, but let's go through a little mini calculation. First, how many 1/3 hours are there in 1 hour? Well, there are 3. There's 3 1/3 hours in 1 hour. That means if you have 3 hours, 3 times as many 1/3 hours, that's going to be 3 times 3 is 9 1/3 hours in 3 hours. So 9 times that 1/3 hour is equal to 3 total hours. A little bit tough. And it even gets a little bit tougher if you look at this and write the ratio to use to solve the proportion. That is, to go from 1/3 of an hour to 3 hours, that's 3 over this 1/3 of an hour. And again, this little calculation right here, 3 divided by 1/3 is equal to that 9. You have 3 hours, 1/3 of an hour for each hour. 3 divided by 1/3 is 9 1/3 hours. So it's going to be 9 times as much time. So 1/3 hours times 9 times as much time is equal to 3 hours. So you're going to travel 9 times as far. 2.5 miles times that 9 is going to give you x. So you can solve for x. 9 times that 2.5 miles. Use the distributive property. 9 times 2 plus 9 times that 1/2 right there is equal to 18 plus 4.5. 9 halves is 4 1/2. Add them together, you get 22 1/2 miles. In the 6th problem, Nancy is making a special mix of M&Ms, 8 cups of M&Ms. 80% of those M&Ms are red M&Ms, and 20% of those M&Ms are blue M&Ms. So how many cups of red M&Ms does she need? That's the x. How many cups of red M&Ms? So remember, percent, once again, it means per 100. So 80% means 80 per 100. And written as a decimal value, it's 80 hundredths. So you can set up the proportion. So it's 80 hundredths is equal to how many cups out of 8 cups? And so the ratio is 8 out of 100. So you're going to make 8 hundredths as much M&Ms mix. So that's 8 hundredths times this 100. So if you're going to cut this down to 8 hundredths of 100, it also has to be 8 hundredths of 80. So you can figure out what x is as 80 times 8 hundredths. So it's this 80 times 8 hundredths. So there's the 80% right there. 80 per 100 times 8. So you can factor out the 10, and you end up with 8 times 8 is 64 tenths. So 64 tenths is the same as 6 4/10 cups. Now you should go through the proportions, set it up, think about it, but you might just go directly to using percent as a fraction. So it's 80 hundredths of 8, which is the same as 8 tenths. Factor out the tens, that's the same as 8 tenths of 8. So 8 times 8 is 64. It's 64 tenths. So it's 6 4/10 cups of red M&Ms. Using a decimal value, that's 80 hundredths times 8. So you see the 8 times 8 is 64, but it's 64 hundredths. 64 hundredths, which is the same as 6 4/10. So it's 6 4/10 cups of red M&Ms. Now it doesn't ask you to do this, but you can figure out the rest of the mix is 20%, and that's 1 6/10 cups of the 8 cups. So if I multiply 8 cups times 20%, which is 20 hundredths, I better get 1 6/10 as an answer, and I do. 8 times 2 is 16. This is 8 times 20 hundredths is 160 hundredths, which is the same as 1 6/10 cups of blue M&Ms.